the zoo. Crocker White Zoo.
How much time did it take to print?
Probably 4 or 5 hours. It wasn't too bad, actually.
Definitely worth it.
Yeah, totally.
All right, everybody. We are live. Thanks everyone for joining in. We are with the hardware hackers and with the balenaFin team today. Thanks everyone for joining IoT Happy Hour. Let's go around the room for some quick intros. I'm David. I'm the developer advocate here at Balena, and I am joined by, let's see, I'll go right across my window here. Anuj, say hello.
Hey guys, I'm Anuj. I'm a hardware engineer at Balena, and I also work on some firmware bits here and there. I'm pretty new to Balena, so I'm also here to find out more about what went into the whole balenaFin project before I joined. So I come with a bunch of questions.
Awesome. All right, Nico, you're up.
Yep, so I'm Nico. I'm also part of the balenaFin team. I've been around a bit longer than Anush, so I'm hopefully be able to answer some of those questions.
Awesome. Tomas, you're a regular.
Hey. Yeah, so I'm Tomas. I'm a hardware hacker, which means I get to build cool projects with Balena. Yeah, I've been here for 6 months, so newish. And I hope I learn a bit more about the Fin too, because I've used it, but not as much as I want.
Cool. All right. Chris?
Hey everyone, I am Chris. I'm the lead hardware hacker at Balena. Just working on building some cool projects to show off features as always. I'll have some cool stuff to show you in a moment if David lets me.
Yep. And Carlo.
Hi, everybody. I'm some sort of veteran. This is the 4th year in Balena for me. And I am the balenaFin lead. So I handle everything from, design to manufacturing to experience with, Nico, Anuj, and others in the company.
Awesome. All right. Thanks, guys. So normally at this point, I go around the room and ask the hardware hackers what they are working on and what they're up to tinkering in their labs. But I think actually it'd be kind of interesting to see what the Fin team is kind of hacking on these days. You don't need to reveal anything that's top secret, but what are you guys hacking on? What kind of parts are on your work desk these days? Anuj, you want to go first?
So a couple of weeks ago, I was working with Carlo and adding camera support for a module that was like a non-standard module in a way, because the way the drivers were structured. So that's one recent thing that I was working on. And I have some display-related stuff, like touchscreen stuff, on my desk. There's this tiny 5-inch HDMI display. But this is for a talk that I'm doing tomorrow. So I'm working on showing off the Balena Dash project. So that's why I have a bunch of display-related things on my table.
Wait a minute. The talk is tomorrow, and it's still in pieces?
It's going to be in pieces.
Those are backup parts. Of course, those are backup parts, right?
Wait. All right. Nico, what are you hacking on these days?
I do have a couple of things going on. So I'm working on a bunch of accessories for the Fin, mini PCI Express based ones. I'm also working on, let me see if that's, some other cool Fin attachments to help on the hardware testing of the story, Fin and other hardware. It's not been released yet, but it's what I'm working on.
Awesome. All right. That's a cool looking contraption you have there. And
That's
then,
some PCB stacked going on.
yeah, so it's
Pretty neat.
PCB sandwich. And then Carlo, what's on your desk? What are you hacking on?
Actually, up
Looks like a
until
pretty clean desk.
today, up until today, I was working on a new setup for our in-factory quality assessment and testing process, where we basically do a bunch of preparation, configuration of the board before it gets to our customers' hands. And I've been working mostly on improving the speed and the quality, so that the process becomes more streamlined, but also enabling future features that you will discover about customizing the fin when you're ordering it, so that we do a bunch of stuff for you before it even gets to your hands.
Awesome.
Yeah.
All right.
And then the cool part about that is that we're so this is part of what I'm working on so too, is that we're gonna be having fins testing fins.
Oh yeah.
So a little good loop, feedback loop. That's it's pretty cool.
Awesome. All right. Well, so I see a couple of people have already joined into the stream. I see that a couple of guys have said hello. Thanks, Bruno. Thanks, Jason, for joining. We are going to be talking about the fin today. The fin, I'm going to let the guys talk to it in detail, but it is our Balena branded custom Raspberry Pi compute module carrier board. So before we get into that, though, just a quick reminder, anyone watching, anyone in the audience, by all means, post your questions into the YouTube chat. We'll curate those, get them over to the team to get addressed. With that, I think probably ready to start us off. For anybody who's watched the past couple of episodes, we've kind of been hinting at, we've said that the balenaFin is an enterprise grade, industrial strength IoT device. A couple of the guys have wondered exactly what that means and what kind of torture we could subject one to. So I've got one here and I have a couple of ideas, but I'm going to go around the room and ask, what exactly do you mean by industrial strength? I mean, can I put this in a blender? Can I break it in half and it still works? Can I step on it, throw it off the top of a house or a building? What are we talking about here?
It really depends on the height that you're throwing it from, the weight of the person stepping on it.
Okay. Chris, I think you might have had a couple of ideas on ways to torture it.
Well, I think it was Tomas who was threatening to throw it into a volcano.
It was Tomas.
I don't have anything quite that deadly near me here, unfortunately.
Yeah, it was Tomas. That was about 2 or 3 episodes ago. He said
the idea was to set up not like a balloon, but lower one with the, those probes that they send into the sun to gather, I don't know, a bunch of science data.
I'd be down for launching a fin towards the sun, like if we can arrange that.
Yeah, that's what I'm saying. I mean, that sounds expensive, so maybe we can do that with a volcano and see
so
we can work
how far we can get.
Yeah, so we'll test it with a volcano first. Okay, that makes sense.
Proof of concept, right?
If it survives, we can go for the sun then. Yeah, okay.
Thomas, don't forget to get one of these.
The heatsink.
Yeah.
Oh, well,
I think it will really help when you're.
Yeah. If you're going to put it into a volcano, you don't want your compute module to be exposed by itself. You want the heat spreader on top of it. Yeah, that makes sense.
Yeah.
Gotcha. Yeah. So we've been talking
about. Make sure you get this when you get the balenaFin from the store.
We've been talking about ways to torture this poor thing for weeks already. So it'll be interesting to hear you guys. So for those who don't know, I live in Arizona in the middle of the desert, and it gets up to about, forgive me, I'm going to talk in Fahrenheit here. It gets up to about 100 and it gets up to about 125 in the summer, and that's the air temperature, but the blacktop and the cement, I have to use a meat thermometer, but I can get about 165 to 170 on
How much is that
concrete.
in real units?
Oh, real units?
76. Yeah, so 175 Fahrenheit is 76 degrees Celsius.
Okay.
76.
All right.
Jesus.
Yeah, so
What?
Yeah.
I'm thinking about setting one outside, and then if I get an IP67 or some other type of enclosure for it, inside of that, I mean, I think I can probably boil water. So we're going to see sometime this summer, I think a few more months away still, we're going to see if this thing can stand up to the temperatures. But
we're already getting some questions from chat. So
already?
Phil is asking, does it cope with vibration better than a normal Pi? Because I'm thinking about in-vehicle applications.
Well,
It actually does. I mean, we can talk about that later. But yeah, let's got some of the features or sort of the design that went.
Yeah. So
into the
all right.
process.
So let's kick it off. I wanted to start off. We'll get to these questions in here. I see them. Yep. Okay. So I wanted to kick it off with a little bit about the history. So can you guys cover some of the background, the design choices, early iterations, prototypes? Like how did this thing come about?
So, you know, as you clearly know, but like for the benefit of, you know, the audience, like
Yeah.
in Balena, we say that we are support driven, right? So we put a lot of effort and care into support and most importantly, in the feedback that we gather from customers, right? So, you know, Balena is a software company. We create a software infrastructure for people, you know, to work on fleet of devices. What we did in the beginning of the Fin, you know, experimentation was basically gather feedback and trying to understand if there was any point of friction that was beyond software that we could help with. So, you know, stuff like what's the, you know, most used device across our fleet? What are the most common, you know, issues and, you know, defects that the, you know, customers experience and how bad they affect their scaling? So we started out the Fin journey by just, you know, understanding from our customers that, you know, most of them were using Raspberry Pis. Most of them were using Raspberry Pis beyond proof of concept. So they were actually deploying them, you know, as production devices into the field. And then after a given, you know, initial amount of time, they will start to experience, you know, sometimes a lot of issues regarding, you know, SD card corruption, power flakiness, Wi-Fi connectivity, and so on. So we literally just started working on the Fin because we wanted to basically keep the strengths from the Raspberry Pi ecosystem that our customers were really valuing, whilst offering something that was, you know, better fit for, you know, their use case. Fortunately, that, you know, the Raspberry Pi Foundation, you know, released this compute module SKU that was meant for, you know, people like us to design around, and that was what started the, you know, the whole, you know, Fin journey. It was just literally just answering, you know, to issues and difficulties that our customers were experiencing. And then, you know, we, being a software company, we had a creative approach to iteration and design. You know, you have a lot of knowledge and experience that normally hardware design companies don't have. Of course, there's also the flip side that we had to learn a lot, you know, while designing. But so we went the full CI experience. So I believe that we did like 8 iterations before getting to the first publicly released Fin, which is the 1.0. And the process was mostly like keeping the experience as good as possible and improving where it could. So there's, you know, selecting components that were known to have good mainline kernel support, you know, and, you know, matching whatever was common interface that you would expect from the Pi. And, you know, every time you know, ended up with a design, and, you know, we made sure that we used it as customers, but also involved some early adoption customers, you know, to provide feedback on, you know, alpha and beta products. And we processed this feedback into iterations until we felt like we had a first solid device. And we just kept doing, like we keep doing it. You know, internally we keep thinking and experimenting on how to improve it. So I believe that the first thing that booted happened 5 to 6 months after we started this journey. And then, you know, it took a long time to actually refine and perfect it. But yeah, this is how we started, and this is how we, you know, we went through it.
Very cool. So that's awesome. That actually leads me right into my next question, which is, so 5 or so months of, you know, the design process and iteration, and going down that journey as you mentioned. But once you've got something that you think is ready, it's ready to be produced, mass produced for that matter, you then get into some challenges I've heard about in the past. I don't know too much about it, but the certification process, and in order to take your prototype to production, Anuj, I know that's something that you're familiar with as well, but can you tell me a little bit about that? I think maybe Nico, you might have some experience there on what that testing looks like.
Yeah, sure. So there's actually sort of a sea of certifications that might or might not apply, or that you might or might not consider for products. I mean, there's sort of a baseline, which is sort of the standard CE or FCC, depending on the market certification, which is like that these agencies will certify that your device doesn't interfere with devices out there. So that's sort of the baseline. Then on top of that, even in those same certifications, you can get like different levels of sort of robustness or shielding, or depending on which type of environments the device will sort of continue working. So there's a baseline, and then there's sort of higher targets you can move to in terms of certification. And then there's other certifications, sort of more industrial focused, where they test on specific, for example, they blast it with EMI, or they blast it with static, and then they will check how the device reacts to that. So we of course did all the baseline and sort of try to get the highest target on all these baseline certifications, and then we did separate testing on how it behaves when the device is vibrating, how it behaves on like on different temperature ranges, and then we of course also selected components that we put on the fin that will withstand all this. So it's an effort of selecting the right components, which are usually more expensive because they have higher temperature range, they're more solid to vibrations and all that. And then there's the next step, which is certifying that the whole thing keeps its promises. So we can talk a lot about certifications and processes, but that's usually how it's done. So you select the right components, and then you achieve baseline certifications, and then you go like sort of move up the scale, depending on what type of customers you're targeting, if their industries sort of require these type of certifications. Some customers, they only require the sort of the results of the lab, and then they don't require sort of the thing to be certified. They can just get with the results of the lab, where they can guarantee
Okay,
that.
now is one of those tests throwing it into a volcano or not? I mean, is that the highest level of certification?
We can do that. I mean, we can do this balena certified. That will sort of include throwing it in the volcano and seeing how far in it still works.
Awesome. All right.
I have a quick follow-up question for Nico. So as I understand it, like you need to apply to, depending on the market you want to sell it, you need to apply to different certifications. I guess it depends on the body or the organism that is responsible for that.
Yeah.
So if you apply to one and then you want to apply to a different one, do you need to does that start from scratch, like the entire process, or is there like a common base, or I guess
Uh,
they are completely separate entities, completely separate tests, and you need to do same thing twice? That's my...
Yeah, in most cases it's not. So you have the main two sort of certifications or agencies are sort of the FCC for the US or North American market, and the CE for the European market. So CE applies to all the European Union countries, and then sort of most of the other countries, with some exceptions, but most of them have sort of, they use one of these two main certifications as sort of a template. And some countries require to add one or two tests to the base. And some others, if you have your certification for FCC or CE, they will just grant it
That's enough. Okay.
For the market. It depends, but that's usually how it's. There's very few markets that require a lot of extra testing.
Huh. It sounds like we
Right
may
on.
actually need to do an IoT Happy Hour episode strictly devoted to this process. And honestly, that's interesting. I think there's a lot of people out there that understand that it is challenging, but there's not, at least at a cursory glance, a whole lot of information on it. Admittedly, I haven't gone down into the rabbit hole of trying to research it, but I'm guessing there's a lot of lessons learned along the way. And Nico is probably a wealth of information. It's really not a bad idea to do an episode focused on that.
Yeah,
sure.
Especially because in a lot of cases there's a lot of gray area, I would say.
Yeah.
You could do it, you could get away with not doing it, those kind of scenarios, and like it's a little like there's no hard yes or no's for some things. So it's like it's very difficult to find like blogs, because then they would have to, like, it's hard to express that in words.
Yeah, exactly. And that whole prototype to production process, I think there's probably a lot of creators out there that would find some value. So Nico, I think you may have just signed up for another episode in the future. Sorry about that.
Yeah, I just want to give a quick shout out to Kimmo in chat there, because he's saying he's got a balenaFin on his desk prototype back from when it was still called Project Amber.
Oh,
That must be early days, Carlo.
Wow.
Yep. That was the first code name. So we're talking about like early days. Nice to see it's still rocking on a desk.
Yeah.
Okay, so
awesome.
I have a related question. Like what's with the name? What's the motivation behind the name? And what's the motivation behind Amber, right? Project Amber.
So, well, code names are, like code names, right? But, it was basically the solid form of what used to be Balena's former name before we did the rebranding. It becomes Amber when it solidifies. So, hardware, there was some kind of, word trickery there. And the same kind of approach was taken for the balenaFin. Is literally, an attachment to the balena body. You can think about it as an extension that allows you to interact with the, physical world.
It all makes perfect sense.
It's all coming together now. All right. So moving along a little bit here, you talked about, you kind of alluded to this already, the features on the board. So I took a look at the balenaFin website, and I noticed a couple of items that stood out that are not part of a standard Raspberry Pi. So things like an MCU, eMMC, PCIe, and a SIM card. So can you give me a little bit of information on the additional components and features that are included then on the Fin?
Yeah, so some of them are a straight replacement of whatever we found, not ideal for professional usage on the Raspberry Pi. Like eMMC is the direct replacement of SD cards, right? So it's the storage medium that the Fin exposes for, the rootfs and whatever you need to store there. And so you have like two family of components, right? The first one is what defines the core that is basically one-on-one compatible, but sometimes better, sometimes at least equal to the Raspberry Pi, and then the features that are added on top of that core set of features. For example, the MCU is an addition that aims to solve two problems that the Raspberry Pi cannot directly solve without accessories, which is analog and real-time I/O, and the possibility to control like deep sleep power states. So the ability to have the device go into sleep mode and absorb very little power, so that power demand, power efficient use cases were accessible. Same goes for the mini PCI socket. We did what we could with what the compute module exposes, so that we could support the cellular connectivity and other kind of attachments that are standard and readily available on the market. So yeah, there are a bunch like MCU, the mini PCI socket, the power circuitry is another big one. Maybe Nico wants to talk more about it, but that was another kind of weak point that we identified from our feedback gathering on the Raspberry Pi, and we tried to improve it.
Yeah, that would actually be interesting to hear about, because again, as an IoT device, power supplies may be maybe unreliable, or depending upon where the device is being placed. You also mentioned deep sleep, thermal and power properties are an issue.
For example, going back to your idea of throwing one in the desert, right?
Mm-hmm.
If you find your device not being able to continually sustain that temperature, but you have business logic that only does like recurrent, chunks of business, of operations, like gathering information from a sensor and sending out to some cloud, you don't need a device to be always on, right? So you can sleep the device so it doesn't produce heat, and therefore suffers less from the heat, and then only power it up when you need to do the operation, and then you sleep again. We have customers that are doing this. They are doing like solar powered smart agricultural traps for identifying insects and other stuff. And temperatures can go very high in summer in these fields. So they found that these sleep cycles basically allow the fin to not suffer at all from the environment temperature, because the spike of computation is so short that it's not relevant.
Yeah, these sort of remote sort of solar powered applications are like very interesting, because they pretty much use like everything that we have. So for example, when you use batteries for solar power, most of the times, if not all of the times, they're not 5 volts output. So you need a power sort of circuitry on the like we want to have the fin, which will allow for batteries to be connected directly to the board without extra things that need to convert power down. And also the use case that you guys were mentioning, where you probably gather the data and then at some point you need to transmit it to the cloud or whatever. That's where the mini PCI Express connector, where you can sort of easily plug a 3G or LTE modem will come in place. So you don't have to have a sort of a USB thing connected that might vibrate, disconnect, get hot, and stop working. So that's a pretty interesting use case, because sort of involves pretty much all the features that we added on the fin.
So like the Raspberry Pi by default accepts 5 volt, right? And that's the only voltage that it accepts. So the fin in like it accepts, I think, 30 volts. Is that right?
32, yeah. Yeah, and it's also a USB based connector, which is not very common to find on power supplies, apart from like normal cell phone chargers. Apart from that, there's pretty much nothing that uses a USB connection.
Yeah. So I think I'll just show.
Yeah, you have there like 2 of the 3 ways that you have for powering the fin. So you have a barrel jack, which is sort of commercial, a common commercial interface. You have the Phoenix connector that is, a stronger connection that usually allows you to do like screw terminal based connectors where you assemble bigger machines or install this device in, cabinets or other kind of structures. And then, of course, we also maintain compatibility with the HAT standard, so you can power the fin from the HAT pins, that being 5-volt only.
Yeah.
Okay, awesome. So that sounds like it's much more versatile than I would say than a a regular standard run-of-the-mill Raspberry Pi. So we've talked about the board itself, the hardware. What about the software support then? So does it just run Raspbian like a normal Raspberry Pi then, or does it run some other operating system? Or, I mean, is it totally compatible across the board to any OS?
So you can just flash standard Raspbian on a fin and boot it. That will basically grant you a core of interfaces working, and then you will need to manually install drivers for the things that we add on top. So we maintain a Raspbian flavor that tries to have everything already set up for people that still want to use Raspbian for the use cases. But of course, being Balena and having the almost unique situation where we control both hardware and software, Balena is definitely tuned to exploit the best out of the fin. We don't try to lock other distros out. Like, we try to have everything as open as possible. You can any Raspbian derivative is supposed to be working on the fin. But of course, being in a situation where Balena sees the fin as a first-class citizen when it comes down to support.
Also,
Gotcha.
perhaps it's a good moment to remind that Balena OS is also open source. So it's not that if you go with the Balena OS, you are locked in or in any way. So you can customize that to your preference.
Cool. I just noticed you had mentioned that it fits hats. I took my Breakout Garden Pimoroni hat and stuck it right on, and it sure did fit. I might need to get some extender pins to raise it up a little bit, but it sure did go right on. So that is interesting.
Yeah, so the design is that it's compatible with standard hats, and of course the small, they call it the FATs, right? The one for the zeros. And then if you imagine extending it all the way to other side, there will be the fin specifics where you will have hats that also leverage the MCU interfaces, that is the connector on the bottom, for additional features. So you want to add a driver motor, for example. If you had this, a fin hat, that you can do it directly PWMing from the MCU, for example.
So one of the things that I see here, it's got the socket on it for the Raspberry Pi compute module. I want to go back a little bit to a question that one of our viewers asked, 10th Concept asked about adding other SoCs. He specifically called out a rock chip part, an RK3399, which has 6 cores. The compute modules have 4 cores. Can I just drop in any SoC, or does it require the Raspberry Pi compute module? I think I've seen other similar, these are called, what, SOMs?
Yeah, so that's the SODIMM 200 form factor, and sadly there isn't a standard that every manufacturer is sticking with. So even if they look the same and they have the same number of pins in the same structure, the pin out would be most of the times different, so they wouldn't just work. We are actually investigating and experimenting with different SoCs and how to extend support for the fin to different architectures. But a straight answer to the question is, like, if you have a SODIMM 200 rock chip module, most likely it would have a different pin out and it wouldn't just work on the fin, because we are sticking with the Raspberry Pi interpretation and execution of that form factor.
Gotcha. Okay, so that makes sense. So perhaps a different variation of a fin or some other type of carrier board would be necessary then if you're looking for rock chip specific part. Got it.
On the software side, though, it will be everything will be ready. Like as I said, like we try to select components so that there is straightforward mainline support. So assuming that you figure the hardware part, the software part should be pretty straightforward.
Okay. So this fin here is it's got a lot of features on it. What if I actually didn't need all of this? Are there ways to remove some of it? When I'm talking about IoT applications, I'm thinking about, can I make the board smaller? Can I make the board cheaper? Can I reduce the cost, by just using what I need? Is there any way I can just sort of, strip this board down?
I think you're muted, Nico.
Yeah.
Okay.
There we go.
So that's interesting because the way sort of volume pricing works on the fin is sort of different as sort of the standard in the hardware industry. So our price, sort of the unit price of the fin is very close to the manufacturing cost. So we're not having a ton of margin on that. So the way you get sort of volume discounts on the fin is not just by purchasing more units. So you get the best pricing in 1 unit or in 10 units or in 100 units or thousands. The way you do that is by what you were saying, sort of what we call depopulation services or processes. So basically, we have a bunch of modules or features that you can choose not to be put on the fin. For example, let's say that you're not going to use your coprocessor or you're not going to use the mini PS Express connector because your application doesn't require it. So if you demand enough units, what we do is we just remove all those components from the board and then just pass on the savings to you. So depending on what is exactly that you need, you sort of have the board that it's right for you. So you don't have any extra features that you're not going to end up using. This starts sort of to make sense in sort of the few hundred units, like 200, 300 units. So if you're buying 10, you probably just use whatever comes with the board. But sort of customization makes a lot of sense when you're sort of scaling up.
That's where I was going with this, was mass deployment. Once you're talking about fleets of hundreds or thousands of devices, and you want to customize and just get rid of features you don't need. I mean, there's obviously, if you save a few dollars per board, that adds up pretty quickly. So very cool. I think that's all the questions I've got. Oh, actually, you know what? I take that back. I'm glancing at the fin itself right now, and I see one difference. I have my Raspberry Pi right next to it, and I see that this one's got 2 camera ports on the fin. Why is that? Why would I need 2 cameras instead of 1?
So one is a camera-only interface. The other one, you can choose whether it's going to be a display output or a camera interface. And if you have a switch on the bottom under the compute model that allows you to decide, the behavior of the second connector. And this allows you to have dual camera. So if you want to do, like, if you have machines that need to, control 2 different, areas, or you want to do like stereoscopic vision applications, you can do that with the fin.
Oh, interesting. So 2 cameras is 3D and depth perception then.
One of the use cases is that. The other, imagine having a rover that is exploring, an environment. You might want to have a front and rear, camera feed. So you need to rotate and, spend, power on the motors every time you want to look back. And it's interesting because like the Raspberry Pi SoC has, these interfaces. It's just a matter of designing the form factor that allows it. So the Raspberry Pi Model B doesn't have a secondary camera connector just because of form factor and cost saving, probably. The SoC supports it. So what we did on the Fin is this clever switching mechanism so that we can still expose, the ability to have a secondary camera, even if you only have the standard two, Raspberry Pi media connectors.
My stereoscopic vision attachment for the Fin I haven't tried out yet.
Oh,
I built this ages ago.
That's also night vision, isn't it?
Yeah, it is. Yeah, it's got the infrared LEDs and the two cameras, and
those are very neat. They have like a photo resistance that controls how bright is the infrared LED, right?
Yeah, that's right.
Yeah.
And I made this little plate so it fits on standoffs on the Fin. I just haven't got around to setting it up yet.
Oh, that is too cool. Well, there's another future episode right there. So actually that raises a good point. I think about IoT and some of the use cases. And we've talked about, you had mentioned earlier, someone who was doing some environmental detection for insects and whatnot. Now you just mentioned a rover. So I could see it being used on a rover with, like you say, a front and a rear camera. That's awesome. What are some other, industries or types of use cases that you've seen thus far?
It's very heterogeneous. It can go, it goes all the way from power control and measurement, factory automation, factory monitoring, to office automation. So, we have, for example, a customer that controls all the access to the building with, fins installed for every door and every room. This way, every time they need to add the credentials for a new employee, they just, deploy an update or even just add, environment variable to their Balena Cloud dashboard, and the whole system accepts, the new credentials. And then anything like, drone control, meaning this is not, is not probably not ideal for, being stuck on a drone, but it's a perfect device for the ground station that controls, one or a fleet of, drones. It's designed to be general purpose, meaning that, you can do a lot of different applications. Usually I remember the cool ones, but yeah, Nico, go on.
Yeah, there's some stuff other customer using it on sort of growers. So stuff that you use to control like the growing of plants, like indoor devices that are getting deployed. And those things sort of move around. They have high humidity or high temperature, and they sort of have very different requirements than a standard Raspberry Pi. So it's being used on that sort of industry as well.
Agricultural use cases as well then.
Mm-hmm.
Okay. Well, I think I have gotten all of my questions answered. Let's take a quick glance at YouTube chat, see if the audience has any other questions that we haven't addressed. Chris, have you seen any others roll through?
Rahul's asking about using the ADC on the coprocessor from the Pi. So I guess he means from the the compute module side of things. How would that work?
So the relationship between the compute module and the MCU has different layers, right? So we're trying to develop and maintain the easiest possible way that we think, most people that are not familiar with MCU programming are going to be comfortable with, which is based on the Firmata protocol. So you treat the coprocessor as, an extension of the compute module, and you send commands that are then executed by the coprocessor. And I know that we are right now you can control already GPIOs, I2C, and we are working on adding support for the IDAC interface that we have on the coprocessor among the Bluetooth radio that the coprocessor exposes. And then if you want to go deeper and actually create your own business logic, you can just develop firmware for the coprocessor, and you can still control it over this common bus, which is a serial bus that you have between the compute module and the coprocessor.
And we have examples for all that kind of stuff on the GitHub repo, don't we?
there is a
Wonder if I can
boilerplate
find the
for
link.
there is a boiler for developing and building your own firmware, and then there is the whole firmata stack ready to be flashed and used, and even extended.
I'll put the link in chat there.
Awesome. Thank you, Chris. I see John has a question. Can you talk about the Bluetooth low energy and some of the lower power modes? BLE, is that included on the board, or do you need a dongle for that?
No, that's included on the board, so it's part of the coprocessor radio. So the coprocessor has its own separate radio from the compute module, and basically that targets the low power application. So basically the way it works is via the coprocessor, you shut down the power to the compute module. So the coprocessor will be the only thing sort of running on the fin. And then you can control sort of the power state of the coprocessor itself. So it has different power modes. So like the regular, like high power mode, idle, and then a couple of deep sleep modes. So depending on what your application requires, is the sleep mode that you will select for the coprocessor. From the deepest state where you will need a physical power cycle of the board to like a less deep state where only a restart will make it work, or like just idle, depending on what the power efficiency that you need is. So basically that's the way it works. You shut down the compute module, and then the coprocessor takes control, and it will sort of dictate what sort of power mode you'd like. There's a blog post that we put out at some point that gives a bit more information on like what sort of current or power consumption you can expect on these different modes. Of course, it will depend on what other peripherals you're using, but it gives you sort of a good overview of what you can expect.
And this is in the context of you wanting to save power and use only the coprocessor, right? Because like the compute module side of the fin has its own radio interface that has Wi-Fi, AC, and Bluetooth 4.2, including BLE. This means that you have a more Linux standard way of doing BLE if you don't care about power consumption, and also you can use both simultaneously. So, for example, having a beacon broadcasting while also exposing a GAD server, something that can actually interact with peripherals. And just a quick example of when you will need, you will want to have the compute module side shut down and use the coprocessor as your radio interface is when imagine having the fin as a gateway that controls a bunch of small sensor or relatively dumb objects in a field. You can programmatically gather or send information from and to them, and then pass it over to the compute module only when you need this information to get outside of the edge, outside of the field, and back to whatever is your cloud interface.
That's actually really helpful. Thanks. I see one more question rolled in. Does the fin have PoE capabilities, or power over Ethernet capabilities?
Yeah, so it has the same power over Ethernet capabilities as the sort of the way the Raspberry Pi is done. So basically, you have a 4-pin sort of power Ethernet right next to the hat connector, so you can put on sort of any PoE hat that's compatible with the Raspberry Pi. You can plug it on the fin, and you'll have power over Ethernet capabilities. And also, since the fin has a higher power range than the standard Raspberry Pi, if you are using this sort of non-standard but sort of widely used passive PoE solutions, you can just, from the pin headers of the PoE hat, you can just connect it directly to the power input of the fin, and you won't need any sort of additional hat. So I think there's an example that we're preparing for how to use that.
Where a user did that.
Yeah.
Yeah, I did that on my LoRa gateway as well. It's super handy because you could just jumper the PoE header straight back into the input because it's such a wide voltage range. I'll paste the link in the chat as well. Hang on.
Your LoRa gateway was PoE? I don't think I knew that.
Yeah, so it's I put a fin outside in a IP67 rated housing, and it's got a LoRa mast and a ADS-B flight tracker mast, and it's powered via one of these Ubiquiti passive PoE injectors. But because I was using the hat for a GPS hat, I just literally put jumper wires from the PoE connector, the 4-pin one, and just fed it straight back into the input on the fin.
Sounds like yet another future episode. Also, one question: was that a screwdriver in your hand? What are you?
I mean, I can't not have a screwdriver in my hand. It's either a knife or a screwdriver.
He only scratches his beard with screwdrivers.
Yeah.
All right. Well, I think I'm looking at the clock here, and we'll start closing it up. Let's take a quick glance at chat to see if there are any other questions in here. I think we have gotten them all addressed, though.
I have a last minute question. It's like choosing a favorite child, but what's one favorite feature of yours? So it's Nico and Carlo, but Chris and Tomas, you as well. Like, what's one favorite feature? Because like it packs a punch, right? Like there are so many things that the Raspberry Pi doesn't do that the Fin does. So what's
I'm going to jump
in
in first and say that PoE feature that I just described is my favorite. I'm taking that before anyone else does.
Okay, so we are claiming features now. Okay,
Yeah, we are,
okay.
Yeah.
For me, it's a hard tie between the MCU, specifically for low power modes enabling, and the mini PCI Express socket for cellular. I think that those two are like the strongest differentiation factor feature-wise from the Raspberry Pi. If I really have to pick, one of the two, I would.
Yeah, I was going to just say that now you're cheating by picking two, so you're leaving less for
Probably.
Nico now.
I would go for the mini PCI Express because, like, modem, even if not ideal, I can add some other way. While being able to control low power modes, it's harder, to tinker or hack together in a different way.
And for me, so I come from a sort of a microcontroller background, so I'll definitely pick the MCU. It gives you sort of a lot of freedom to do stuff that's hard to do on the compute module running on Linux. So there's a lot of low level sort of real time or low power application that you can do with a coprocessor that you cannot do on a standard sort of Linux running microprocessor. That's definitely my favorite feature.
And if you think about it, the main processor in the setup changes really based on what you need. Like, you can use the Fin with the coprocessor being the main, architect of business logic, and then it only uses the compute module when you need to, communicate with, the outer world. And that basically flips the relationship. So the coprocessor becomes the compute module. If you think about it.
So your microcontroller board also has a Raspberry Pi on it.
Exactly, right?
Yeah, exactly.
Just like on the side.
Awesome. All right.
The mic drop a moment, right? Oh, by the way.
Yeah.
Well, I just put into chat, in the YouTube chat, a link. I want to remind everybody actually about a pretty cool project that we're participating in with the United Nations Development Program, and in coordination with Hackster.io. So there's a challenge right now running for COVID-19 Detect and Protect. There's some big names involved as well: Google, Microsoft. I see you're on the list also, NVIDIA. And we are actually donating 100 fins to this cause. So ultimately, the challenge to the community is to develop cheap detection and protection systems for the COVID-19 pandemic. There are AWS credits available. Obviously, like I just mentioned, there's going to be some fins available as well. So for anyone out there who has some ideas, obviously I've seen all of the posts about 3D printing and homemade ventilators and other things that, help the cause. But if you have any other creative solutions, by all means, get your submission in You may actually end up with a fin and some AWS credits to boot. I think that's about it here. Anybody else?
We didn't hear what Tomas's favorite feature of the fin was.
Oh yeah.
Oh yeah.
Wait,
He's
we skip
actually very
Tomas?
yeah.
I was
Oh my goodness, Tomas
Don't worry,
got
David.
skipped. I'm sorry. Go ahead. Go ahead.
It's okay. It's okay. I think the favorite thing for me is not having to mess around with SD cards. So the memory,
Yeah.
the eMMC is super nice.
I think
SD cards eventually they all fail, even if you spend big money on the best you can possibly have.
Yeah, that's
Eventually
a good point, because
fail.
like when you're comparing the fin and the price of what the fin is to a Raspberry Pi, say $35, you're not including the cost of a decent SD card in that $35.
Yeah.
Well, you're also not including, like a decent PSU, a decent,
Right.
whatever microcontroller you need if you want to do real time, and whatever HUD you need to basically match, the features of the fin. You get really close, or if not beyond the fin cost, if you want to match the features that it offers by just, adding stuff on the Pi.
Especially the power circuitry, I think, because it's such a wide range.
And then you need to certify your bundle of accessories.
Yeah.
Which leads us again to the certification discussion, which something that you don't need with the fin because it's already a certified device.
Awesome. All right. Well, thank you very much, guys. Thank you, Carlo, Nico, and Anuj, for joining in.
Our pleasure.
Yeah, definitely appreciate it. I'll go ahead and end the live stream here. If anyone does have any other questions, by all means, our forum has a fin category. Post them in there and we'll get them answered. All right. Thanks, everyone. Bye, guys.
Yep. Thanks, everyone,
Bye.
for joining us.
Everybody.
Bye, guys.
Bye.
Bye.
Bye.